I am your math teacher, Meena Laxman. Now let's start with the first chapter, real numbers. Let us see what are the numbers included in real numbers. The smallest set in real numbers is the natural numbers. What are natural numbers? Natural numbers are the numbers which includes 1, 2, 3, etc. till infinity. Then comes the next set, whole numbers. What are whole numbers? Whole numbers include 0 along with the natural numbers. It includes 0 along with the natural numbers. Then comes the next bigger set, integers. What are integers? Integers are the numbers which have the negative numbers as well as the positive numbers along with 0. Integers are the numbers which consist of negative numbers as well as positive numbers including 0. Then comes the rational numbers. What are rational numbers? Rational numbers are the numbers of the form P by Q. P by Q. This P numerator is an integer. This P numerator is an integer. Similarly, Q, the denominator, is also an integer. But we have a condition that the denominator should always be not equal to 0. Let me give you an example. For rational numbers, it is of the form 1 by 2, 2 by 3, minus 5 by 7, minus 9 by 10, etc. These are rational numbers. Rational numbers are numbers of the form P by Q. The numerator is an integer, denominator is an integer, but denominator should not be equal to 0. Then comes the irrational numbers. Irrational numbers. The numbers which are not rational numbers are called as irrational numbers. That is, irrational numbers are expressed in the form root 2, root 3, minus 1 by root 11, pi, and so on. What are irrational numbers? The numbers which are not rational numbers are called as irrational numbers, and we have examples as root 2, root 3, minus 1 by root 11, pi, and so on. So, real numbers includes rational numbers and irrational numbers. Let us go in depth of these rational and irrational in later classes. Now let's see what's Euclid's division lemma and Euclid's division algorithm. In the earlier classes, in the 7th, 8th, we have seen what is meant by divisibility. Now let me give you an example, 148 and 124. Which number is smaller? Which number is smaller? 124. So we will write 148 inside and we will divide by 124. How many times this goes? It goes one time. So 124. Now what is the remainder? 4 and 2. So it is 24. So we can write 148 is equal to 124 into 1 plus 24. This 148 is the dividend. This 124 is the divisor. This 1 is quotient. And 24 is the remainder. So using this, we have the Euclid's division lemma, which states that A is equal to BQ plus R, that A is the dividend and B is the divisor, and Q is the quotient, and R is the remainder. Using this, we can understand very well Euclid's division lemma. Euclid's division lemma states that A is equal to BQ plus R, where A is the dividend, B is the divisor, Q is the quotient, and R is the remainder. Now, in order to find the HCF, we have Euclid's division algorithm. In order to find HCF of numbers, we have Euclid's division algorithm. What does it say? Applying Euclid's division lemma, and we have to get the remainder as 0. Till the remainder as we are getting as 0, we have to use Euclid's division lemma and proceed to find the HCF. Let us consider the same example 148. Let us consider the same example 148 and 124. We are going to find the HCF. We know 148 is the larger number. So let us divide 148 by 124. It is very clear. It's very clear. 124 goes 1 times in 148. What is the remainder? Remainder is 24. As Euclid's division lemma, we can write 148 as divisor 124 times 1, the quotient, plus the remainder 24. Now what's the next step? We have to continue the same process, Euclid's division lemma, until we get R is equal to 0. Here what is your R? R is equal to 24. We should get R is equal to 0. Until we get R is equal to 0, we are going to proceed the same lemma. So, in order to get R is equal to 0, let us consider the next two set of numbers 124 and 24. Which is larger? 124 is larger. So, we are going to divide 124 by 24. How many times it goes here? 24 into 4, 16, 1 and 9. The next one, 24 into 5 is what? 24 into 5 is 120. So which number we will be considering? Either 96 or 120. We will be considering 5 times. So 5 times 120. The remainder is 4. So as Euclid's division lemma, we can rewrite 124 as 124 is equal to 24 into 5 plus the remainder 4. What does our Euclid division algorithm says? We have to get the remainder as 0. There should not be any remainder. But here we got the remainder as 4. So we have to continue the same step again. Consider the set of numbers 24 and 4. Now, which number is greater? Either 24 or 4. 24 is greater. So, divide 24 by 4. How many times it goes? It goes 6 times. So, exactly it goes 6 times. Now, what is the remainder? Remainder is 4. Sorry, remainder is 0. So, now 24, the dividend 24 is equal to divisor 4. How many times it goes? 6 times. What is your remainder? Remainder is 0. Now, when we consider 148 and 124, we are using Euclid's division lemma and finding the HCF. While finding the HCF, we are applying Euclid's division lemma and we are getting the conclusion as 4 as our HCF. So 4 is the HCF of 148 and 124. This is what Euclid's division algorithm says. Applying Euclid's division lemma, we have to proceed further steps until the remainder is 0. While we get the remainder as 0, that final answer is going to be our HCF. In this video, we have learned what are real numbers. In the next video, let's go in depth with real numbers. If you have any doubts, leave your comments in the comment section below. Thank you for watching.